to get to your email address. So make sure you're getting my emails. Okay, make sure you're getting my emails. All right, so what I said in that email was I want to emphasize the importance of these quizzes. And what I'm going to do is, starting with today's, for the rest of the semester, I will replace your lowest exam score with your average of the quizzes, if it helps you. If that helps you, okay? So I really want you to take them seriously, because it's the whole point here is that everything is building. All these ideas are building one on another. You should see ideas coming in groups, not isolated sets of exercises. And so you have to stay on top of it. You can't, oh, if I get behind a week, that's fine, I'll just get caught up. That's going to be a disaster. So the thing about the quiz is it's a good chance over the weekend to get yourself up to speed and be ready for the quiz, which will really help you when comes exam time. Okay? So for Wednesday, I've already posted, hopefully you've started that work over the weekend. It's number 1 through 5, and it's Module 2, Section 3. I'm going to also include Module 2, Section 4, and include some reading and reflection on the next section. So that will be up by 5 p.m. today, okay, with the next section, Section 4, which we will introduce shortly today, and then you'll just read and do reflection questions, and then we'll hit that hard on Wednesday. Questions about stuff like that? Again, if you want to go over your exam, you can come to my office hours or any of the 3 TAs' office hours. Not Serene, sorry, I didn't give her exams for you to look at, but they have blank exams and they have your full results, what you put on every item. So I encourage you to go over that with them. Take as long as you want to review the exam that you took, okay? And you can do that this week, or you can do that the week before the final, or you can do that in November. It does any time in the semester. You're welcome to do that. Okay, any questions about announcements type stuff? Okay, so fully updated homework for Wednesday will be here by 5. Let's go, quiz. Okay, so real quick review. 2 quantities represented by x and y changed together such that we said the change in one quantity is proportional to the changes in the other. And there were 2 mathematical results of this. 2 mathematical results. The first one was that every change in y is a constant multiple of the corresponding change in x. And the other result? Maybe? Okay, the other result was that the relative size of the change in y to the change in x was constant. All right, and in both cases, that value of k, that is the value of the constant rate of change. Negative 25 pounds per cubic foot, for instance. Or $2.75 per pound, right, the constant rate. Okay, so review of slope. We talked about lines on Friday. How is slope calculated? Change in y. So slope is just another term for the constant rate of change. We said we kind of got to erase this idea that slope has some kind of visual meaning of inclination or steepness. It'd be very easy to change the scale on one of the axes, and the steepness changes, right? But the constant rate doesn't, and the slope doesn't. So the slope is synonymous with constant rate of change, not steepness. Okay? How many changes in x and y exist here? Yeah, okay. So we're taking them in pairs, right? There's an infinite number of pairs of delta x and delta y, and if we have constant rate of change, that ratio then is always the slope, no matter which pair we choose. Okay, so we have we've developed this last time. If you have a point AB with a slope of m, we came up with point slope form of the line. Basically, our x minus a, what was that? What was x minus a representing? Change in x, m times x minus a. Change in y, add initial y, it gets you the new y, and if x is allowed to vary, then you get its corresponding y, generating all points on the line, right? Every point on the line. Okay, so now that we've, and you'll do this process again for your homework if you haven't started already. You're going to practice this process of delta x first, delta y, then add the initial value of y to get the new y and build the equation of the line. But once you pay your dues, once you get it, then we can just use this. We don't have to go through that process every time. You have to understand it and be able to do it. But once you've mastered it, then you've earned your right to use it. Which means if you have a point, any point on your line, and you have the rate of change, the constant rate of change, you can just plug it into this form, and you have the equation of the line. Okay. Again, you have to know the meaning though, or where it came from, and be able to do that yourself. Okay, so in this form, when x equals a, you see that if you plug a into here, that all is 0, and you get y equals b. So that gives you a point. And the function has rate of change m. Okay. And what is that m? That is our constant rate of change, delta y over delta x. Okay, so let's start something new here. We got a couple minutes. Piecewise linear functions. All right, so piecewise linear functions means that a function has a constant rate of change, but it has different constant rates over different intervals. Okay, it has a constant rate of change, but then over different intervals, that constant rate changes, or the constant rate is a different constant rate in different intervals. All right, so let me make that bigger. Is that too small? Let's try that. Okay, let's try this again. See if that's better. So here's a scenario. Jacuzzi, a small whirlpool, is square in shape. It has a step on all sides. You're sitting. All right, the water height is 35 inches, and the step is 16 inches tall from the bottom. Okay, so when filling the jacuzzi, every 20 gallons of water added makes the height rise 2.5 inches in the bottom half, and then when the water level reaches the step, then every 20 gallons creates a rise in height of 0.9 inches. So here's a cross-section of the whirlpool. Like if we just slice it vertically and looked at the walls and the bottom. So very important. So what are we going to do? So it's empty, and we're going to start filling it with water. Okay? Here it comes. Here comes the water. So what I want you to do is come up with possible values of x, y, delta x, delta y, and k. Go. So I'll give you that one, so make sure we're on the same page. Okay, so what is y? Water height in inches. Okay, so delta y is change in water height. What's k?
Either 2.5 or
She's saying there's two values.
Yeah.
There are two values. Okay, so what is the first value?
2.5 over 20 with y is between 0 and 16.
Right, so we're going to take the change in y of 2.5 inches, change in water height over change in gallons, and what do we got for value for that? 0.125? And the units on that? Inches per gallon. Right, before the step. That's right, before the step. And then after the step, once we get up in here, what is it? 0.9 over 20. So because for every 20 gallons, we only get less than an inch. Let's get a number for that. Anyone got it? 4 or 5? Confirm that? Somebody else? 0.045. Cool. All right. Okay, so we want to create the linear function, or the function for this, or the linear equation, which is going to consist of what? We have constant rate of change up to the step, and then suddenly the constant rate of change changes. Okay, so we want to model that. And I need a blank screen for that, so I'm going to come over here. There's my water, so I got a little blank space over here. Let's do this in blue. Okay, so remember what our point slope form is: y equals m times x minus a plus b. So in this first part, do we have a point AB? So in this first part, do we have a number of gallons and corresponding heights? That would be our A and B. What? Remember what x is. X is the number of gallons. Do we have a number of gallons and corresponding height for this first part of the hot tub when it's filling up? Pick your easiest one that you've got. 0 and 0, right? When the 0 gallons of water gives you 0 height. So make it easiest on yourself. And what is m?
1.8.
Right. So we're gonna call our function f, and we'll use f1 to mean the first part of it. So f1 is the name of our function. We know x is the number of gallons, and the output is height. So we get m is our 0.125 times x minus 0, then plus 0. So it ends up being, I'll write it out. That's fine. And so it turns out to be 0.125x. Oh, but I guess I need to tell you how many gallons it takes to fill up the bottom, huh? I didn't tell you that. Okay, so now I need to tell you that. Oh, no, you can do that. So, yeah, so this was how many inches here? 16 inches. So how many gallons would that be?
16 times constant. Right?
You're going to times it by 0.125? Yeah, so for 16 inches, there's 0.125 gallons per, or inches per gallon, right? Inches per gallon. So how many gallons in here? What is it? 128 gallons in the bottom. All right, so now we got F2. So F2 is going to start off. So we need a point, again, so we're going to go back to the point slope form. We need a point AB, and we need M, and we can write what the height, the relationship of height and gallons is. So what is our point AB? A is the number of gallons, so that's going to be right at 128, right? What's the height going to be?
No.
16. When 128 gallons are in there, we've got a height of 16. And that's going to be our starting point now for the next part filling up. What's our rate of change here?
0.0.
So you can make this a lot prettier on your paper. This is going to be 0.045. So let's just put this in graphic so we can just take a look at it. We'll put in graphic calculator real quick. So I'm going to have to erase what I've got. So you've got it written down. You'll be telling me. Okay, here we go. Okay, so we're going to find a function f. Whoa, that's small. Okay, so here's how we do this. So what was our first, we had, the rate of change was 0.125, and that equation just became 0.125x, right? So if you do Control A, oh, you need to do that first. So if you do Control A, you can get these functions that split it into, because our functions split apart, right? You've got the one line, and then we got the other line. So after you hit equals, when you define a function, if you hit Control A, that's what that does. So we said this is 0.125x. And then the other one was 0.045 x minus. So in building that second equation, do you see how convenient that point slope form was? Because if you do slope-intercept, then you'd have to kind of back calculate, figure out what the y-intercept of that second line was, and then it wouldn't really have any meaning. This is much easier. We got our point, 128.16. We found the constant rate of change, so we can just set up that equation. So then how do we graph it? We do that here. So you mean in terms of, oh, right. Thank you.
X less than 16 for the top one, greater than or equal to the bottom.
If 0 is less than x is less than 16.
We took to a comma.
Let's see if it turned out. Something's wrong. What did we do wrong?
Less than or equal to 16. The bottom one has to be less than or equal to 16. The picture including 16 in the bottom one.
That's not going to change the fact that we got a big jump here. Why is there a jump?
Oh,
All right, I'll figure this out later. What happened? Yes? Why?
Yeah, those are values of the height.
Oh, we need gallons. So 128. Is that right? That's what we need. Yeah, those are values. So we need 128 to, let's just do greater than 128.
You could do height though.
That's it. No, you can't do height, right? So it's defining these on intervals of x. So from 0 to 128 gallons, we have a certain constant rate, and then starting at 128 on, which we didn't put the final value, we get a new rate. So it's filling up more quickly, and then it suddenly starts filling up more slowly because the pool gets suddenly wider.
So instead of having to figure out gallons, can you just put between for y is
No,
0 to 60?
no. These piecewise functions are defined on intervals of x always. I mean, you could, but it's very inconvenient. So they're always defined on intervals of x. Okay, so remember, I'm going to finalize the homework by 5 o'clock today.